Hi, my name is Eric Hibbard, and for this session, I'd like to do a storage security year in review. So just touch on some things that have happened in the last maybe 9 months or so that we think might be of interest to you. So first, let's start with a threat summary. Probably no real surprises here. We're seeing continued ransomware, data exfiltration, kinds of attacks. These have been ongoing for a while, and sometimes they're called hybrid attacks. We're definitely seeing lots of those. We're seeing supply chain attacks. Right now, service providers are one of the preferred victims. Cyber attacks in general, we're seeing nation state actors going after critical infrastructure. Healthcare is a popular target. And of course, organized crime continue to hit banking, finance, and government sites. And then there's data breaches that could fall into any of those above, but we're seeing lots of new malware, lots of vulnerabilities that are being exploited. And maybe a new development is that we're seeing that the attackers are beginning to use artificial intelligence to facilitate some of their activities. Um, so with that, moving on to how are we dealing with, how are we countering this? Well, as you can see on this slide, there are a lot of standards and industry players who are operating in what I would call the storage security space. You could actually do probably a 2 or 3 hour talk on just what each one of these is doing. But if you look sort of on the left-hand side, you're seeing more of the formal entities. So these are, ISO, IEC, ITUT, which, the WTO tends to favor from a standards organization, and then how those three are sort of plugged in and interact with each other. And moving to the right, you see more of the industry players, and this is where you see things like specifications, in the storage world. All of these, in some fashion, are using standards and specifications that relate to storage security in some fashion. Okay, so I'm going to touch on some specifics. If you've heard SNIA security talks in the past, I'm sure you've heard reference to the ISO 27040. This is the second edition. It was finally published in January of this year, 2024. It's definitely comprehensive coverage for storage security. It includes requirements as well as guidance. The previous edition was just guidance. So that's the difference between shoulds and shalls being requirements. It also includes some auditor checklists in the back. In the first edition, there were some sort of hints as how you could prioritize. Well, now with the difference between requirements and guidance, that's a lot more straightforward. The structure of the document is completely changed. It's aligned with the new 27002, which is one of the important 27000 series security standards. So the controls are basically in the form of organizational, people, physical, and technological. As you can guess, technological is the sort of dominant set of controls here. It also defers to the IEEE standard 2883 for media-specific sanitization. The content that was in the previous edition has basically all been removed. Lots of new controls covering different technologies. So IPMI, NVMe over fabrics, storage system security, the systems themselves, data archives and repositories. And sort of in addition to backups is a sort of complementary cyber recovery mechanisms. And related to this is there is this new 27002 that came out in 2022, and it actually made references specifically to 27040 for things like backup security and media sanitization. And this happened actually before this second edition of 27040 came out, but it wasn't locked into that 2015 version of the storage security standard. All right. I mentioned already the IEEE 2883, which is dealing with storage sanitization, came out in 2022. Work in that space has continued. So there are at least 3 projects that are sanitization related. Looking at these are guidance standards, so looking at how to use storage sanitization methods, dealing with virtualized or cloud sanitization, which in 2740 was known as logical sanitization. And then a new project to deal with. So what does it mean for purge and destruct kinds of mechanisms? And how do you deal with new forms of storage technology? And there's some updates to the 1667 standard around discovery, authentication, and authorization and host attachments to storage devices. Also related, if you're familiar with the XTS-AES standard, which is IEEE 1619, it is undergoing a revision to clean up a few problems that have been found, but more importantly, working closely with NIST as they want to update their special publication 838E, which allows XTS to, or facilitates XTS-AES being an approved mode of encryption for FIPS 140 certifications. So when this is all done, there'll be a new version of 1619, and the 838E will basically point at this new version with some wrapper text explaining any sort of caveats or issues, things of that nature. In the trusted computing group, also very active in the storage space. In the last 9 months to a year, we've seen the Keeper IO, SSC, and application note was published. There's a test cases document that's currently under development. There have been some adjustments to the Opal SSC, and there's a new version 2.3, which is currently under development, getting pretty close to at least public review stage. Also, the storage architecture core specification is undergoing revision with a target of eventually coming out with a version 3.0. And there are multiple feature sets that are either in revision or development, at this point. And many of these are complementing, for example, the Opal SSC. Elsewhere in the Trusted Computing Group, the Test Station Working Group has come out with a Test Station framework. So this is part 1, dealing with terminology, concepts, and requirements under development. And these are under development. And under the DICE Working Group, there's a protection environment specification that's under development. The device concise evidence binding for SPDM is published, as is the hardware requirements for a device identifier composite engine. So if you're interested in topics of evidence management and device attestation, these are documents that are probably of interest to you. Moving on to the Open Compute project, and specifically looking at some things around security and storage. The OCP Data Center NVMe SSD specification version 2.5 was published around October or November of last year. This represented a pretty significant update to security requirements from the previous version. Also, in about the same time frame, OCP published the materials around Calyptra, which is a system on a chip root of trust specification and RTL. And again, the version 1.0 of that is now out. There were a couple of announcements that came out, and one of those is the OCP layered open source cryptographic key management, or as it's commonly known, OCP lock. This activity is under development. And the OCP Security Appraisal Framework and Establishment, or SAFE program, has been established. So under SAFE, the idea is that your firmware, in a product could undergo an assessment or evaluation based on some established criteria. by some approved assessors. All right, moving on to SNIA. Some developments this year. There was a couple of white papers that were published. One was dealing with encryption and key management. The other one was dealing with fiber channel security. Both of these papers are referenced by the new 27040 standard. What basically happened in 27040 is there was previously tutorial material and annexes. That tutorial material has all been removed, and instead, it's now pointing at documents like these two from SNIA. There's actually a third document referenced down at the bottom here, the SNIA Data Protection Best Practices. That paper is under development within SNIA, and it will be a pretty significant rewrite of the first edition of that paper. Also, SNIA has had multiple versions of its TLS specification for storage systems. And the version 2.2 is currently under a revision, and it's being carefully coordinated with the ISO IEC 20648. So the second edition of that standard is being produced. And these two will, when they're both published in final form, will be synchronized. Some other activities that are worth taking note of is within the DMTF. There's the component measure and authentication, or CMA, SPDM, and PCIe IDE activity. Think of this as a transport that will allow IDE, which is as you can see down below, the integrity and data encryption mechanism. So this is a way to get link encryption that can be used with certain kinds of storage devices. Also, there's the secure protocol and data model, or more commonly known as SPDM. Currently, there's 1.0, 1.1, and 1.2. 1.2 is the version that seems to have the most uplift at the moment. 1.3 was published in May of last year, and work is currently underway for a version 1.3.1 with the expectation that in the coming month or two, we may see new versions of this new version coming out. And although it's flagged as a minor release, there are a lot of changes between the 1.3 and the 1.3.1. Lots of enhancements and cleanups. Under the PCI SIG, we definitely have the PCI Express, IDE, as I mentioned earlier. This is looking like it's going to be a tool to secure communications between hosts and storage, which is something that historically there's really not been a lot of support and capabilities. So the specification's basically done, and what we're seeing is the vendors are moving in a direction where both the host side and the drive side, if you will, have to implement this. Then got to deal with these corresponding interoperability kinds of issues, and I would say we're kind of in that space right now, which leads to the next item is the TDISP, or PCIe Trusted Execution Environment Device Interface Security Protocol. Bit of a tongue twister. Probably the easiest way to think of this is you could actually have a trusted VM that wants to talk to some part of a storage device and do that in a complete secure manner. And TDISP is the mechanism that will basically allow you to do the communication between those sort of two trusted endpoints, if you will. The TDISP runs over PCIe IDE, So you get link encryption. TDISP handles the communication between the trusted execution environments. And to set all this up, you most likely will need something like SPDM that will allow you to establish the keys that get used by IDE, which then gets consumed by TDISP. As you can see here, there's some layering that goes on, even more pieces than what I just described. But looking out to the future, this is the direction that we're seeing that the storage industry is going to be able to play in more secure kinds of settings, complement things like confidential computing, things of that nature. A couple other things to pay attention to if you're into CXL. The 3.1 specification is definitely out. There's work on follow-on versions. There are a lot of security capabilities that have basically been specified. We're, I would say, at a point from an industry perspective of looking at the security capabilities, trying to understand, the implications and considerations. To give you an example, if you're looking at a situation where you're sharing memory between multiple servers, that could present some challenges. So how do you keep those servers from potentially intruding on each other? Well, the answer might be some form of encryption. But then you have issues of, so where is that encryption performed, and how do you manage the keys, and how do you basically sustain the high throughput rates that typically are expected with with memory? So CXL is definitely got some interesting capabilities specified. We have not seen, at least so far, where some of those mechanisms are being implemented yet. But depending on future use cases, it's very likely that some of the security functionality is going to be needed. Last on the list is NVMe over fabrics. And from a security perspective, again, this is in theory going to allow sharing of storage devices in the NVMe world. And so to do that with additional security, this is where we're seeing the use of transport layer security, or TLS, to help deal with the link encryption and potentially some element of the authentication. So lots of moving parts here. Many of them were at a point, as I said, where specifications are done or nearly done. Use cases are being put together, and then the vendors are collectively looking at, so just what do we need to have now, and then the near future, and maybe further out. So that's a bit of what's going on. Next, a little bit about post-quantum cryptography. You probably noted that encryption was a topic that is running through a bunch of these things. So in terms of developments, NIST has basically released three drafts, FIPS 203, 204, 205, that are essentially specifying some algorithms that are going to help with quantum computing in the future. And then sort of on top of that, or in conjunction with that, the NSA has released the CNSA version 2.0 materials. And what's notable is the timeframes, the timelines that CNSA basically lays out. This is one of the few vehicles, if you will, that are basically putting a line in the sand that says you need to be using these some of these algorithms, depending on how you're using the encryption key management functionality, by certain dates. And those dates are the 2030 timeframe and 2033. Now, what's important to keep in mind is that's fully in use. And so that means a phase-in period is going to happen in front of that. And that's some of what we're seeing with the materials in CISA. So this is definitely hitting the storage industry pretty quickly, because from a supply chain perspective, for these to be met in government facilities, it means suppliers and their suppliers need to be moving fairly aggressively. So we're looking at 2025, 2026, maybe 2027, where products have to have some of this functionality. And of course, the state of the algorithms are their draft, although we expect in the not too distant future those will be dealt with. So just wrapping things up here, and I know this is a bit of a whirlwind tour, but that said, we're seeing that the threat landscape is continuing to evolve. We are definitely seeing lots of security requirements coming in for storage. They're on the increase. In particular, we're seeing attestation and link encryption. And we're also seeing platform level as well as device level, inside of the device level kinds of security mechanisms being required and developed. The complexities and interdependencies are increasing. The example I gave with TDISP is a good one. It's not alone. There are other scenarios that come to mind. And I think fairly worrisome for a lot of industry players is what's going to happen with post-quantum crypto requirements and the timelines. And this PQC is definitely poised to be disruptive to both customers and vendors. This is not going to be an easy transition. It's not going to be instantaneous. So everybody's going to have to sort of figure out how to make this work. So that's it for a summary. Please take a moment to rate this session. We definitely value your feedback, and it does have an impact on what kinds of sessions we hold in the future. And thank you very much for your time.